In this video, I want to look at some common considerations, perhaps errors, that you'll encounter when you're working your sensitivity, your analysis of uncertainties with the variables and turning them into graphs. Some common issues to look for. In this example, it illustrates a few aspects of what I would call good presentation. You'll notice in this one that the vertical axis, the y-axis, is relatively hard to read because it hasn't been formatted to dollars or with the familiar commas to distinguish thousands and millions and so on. So that would be a nice little formatting exercise for the vertical axis, the y-axis. Likewise, the horizontal axis isn't very transparent, again because of the commas, but also because neither axis actually has a title. And so putting your titles on is useful. The titles should say what it is, what the units are, and gives thought to the fonts and the number size and so on. You don't want to be too fancy, but you do want to make it easy to read. A third point that you can take from this graph is that because it's looking at both rent and property growth, you'll notice that the NPV tends not to be very much impacted by the level of the rent for any particular property growth rate. This suggests that the property growth rate is the more important element in what is driving the NPV. It does look like the property growth is the driver there in terms of the investment attractiveness. When you're preparing a report, you have to think about your reader. They're usually not as educated in this area as you are, and so they may not be able to see these things. And when you write your comments on your graphs, keep in mind that you're educating the reader. You'll be wanting the graphs to be as easy to communicate the key ideas as possible, and you'll also want to put a little bit of a text under there to actually explain to them what this is actually saying. In this case, the model is relatively indifferent to the rental rates, but property growth does have a bit of an effect. Looking at this a little bit more deeply, some people might want to look at it and say, well, is it best to have the rents across the horizontal axis, the x-axis, or would it be better to use the property growth rates because they seem to be where more interesting things are happening? I'll let you give some thought to that, but it can be useful to give consideration to that. Certainly the gradient on the lines would be more impressive if you transpose the rent and the property growth, so the horizontal axis becomes property growth rather than rent. On the other hand, if you did that, it wouldn't be quite so obvious how insensitive the project is to the rent. Now, this is important from an investor's point of view because they want to know which variables are important for them to consider and which ones they don't have to worry too much about. And so in this case, I would say that an investor should be sweating on the property growth trends and therefore looking more closely at what's going to drive that, whereas the actual rent, maybe $5 or $10 a week or whatever it is in practice, is not going to make a great deal of difference to the investment attractiveness. Okay, so we can learn a fair bit from just that example of a graph. Let's move now to another graph, and this one points out some interesting features. One of the things that you'll notice about this one is the kinks. Whenever you see kinks in a graph, in the trace on a graph, especially when you see it in a pattern coming across, either the kink is telling you something curious about the way the cash flows are behaving as a result of the independent variable, the x-axis variable, or there's an error. And as often as not, it's actually telling you about an error. So that's a good thing to be onto before you issue your report. The last thing you want to do is issue a report with any sort of an error in it. mathematical or presentation or what have you. In this case, let's look at them. When you see kinks between the first and second data point, often that's because what is being graphed here as the first data point is in fact the axis values. So when you see a series of kinks on the second x value, immediately go back and check that the traces, the lines on the graph, are in fact only collecting the answer, the dependent variable values, and aren't picking up something from the labeling or the independent variable labels. And so that's a very common cause of kinks, and usually you'll see a whole series of kinks all at this point on the second data point. Okay, this one though has some more kinks in it. This kink in year 5, and it does seem that the 9% rate somehow is misbehaving at this level, quite out of character with the rest of them. And you can ask yourself what's going on here. It might be that there is some peculiarity there, maybe with the way that tax deductions and so on are working. Capital gains tax can have a kinky kind of effect. One way or another, investigate the kinks, any other kinks, say this kink on one trace in year 5, to satisfy yourself that first of all your mathematics is correct, your graphing is correct, but then also to tell your reader the story, because the reader might be very interested in the story behind what's caused that almost uncharacteristic kink. So 2 things about kinks: either you investigate them for the error, either mathematical or in terms of the way the graph is constructed, or it might tell some interesting story for something that the investor might want to look out for. We'll now look at another graph. This one also has a kink. And you can look at that graph and you say, oh, that's really peculiar. It looks like there are some really interesting and unusual things happening to the internal rate of return as market growth changes, and especially around this market growth level of 1%. You can ask yourself, well, what would happen if the number was really supposed to be where the cursor is here? Then perhaps we might have had a nice smooth curve going all the way down through all the data points. So it's not as though there's 2 kinks here. The kink at this point is because perhaps there is something causing this calculation of the 1% level to be in error. And so it's important when you work with these to see what story the kinks are telling you. Okay, this is illustrative of the importance of getting your calculations, your modelling and your graphing right before your report is issued to your client. Remember, once it's issued to the client, you're responsible for it. You don't know exactly who's going to be reading it, how much money is going to be laid on the table as a result of your report, and therefore how accountable you may be in the future. Something as simple as putting a kink in the graph might cause a bad decision, which could cause you to end up in court, which could be very inconvenient, perhaps expensive, and at worst could ruin your career. So it's worth putting in the time beforehand to get these things right.